Today our topic is functions, but we're going to start with a whole bunch of vocabulary. So our first vocabulary word is a relation. A relation pairs inputs with outputs, and when a relation is given as ordered pairs, the x coordinates are the inputs and the y coordinates are the outputs. So there's a bunch of different ways that we can represent relations, since basically it's pairing your inputs and outputs. One way that we might see a relation is as a mapping diagram, where we've got a circle of inputs and outputs and arrows that take you from the input to the output. We could have them in a table like this, where we have a row of inputs and outputs, or it could be columns of inputs and outputs. As ordered pairs, like already stated, in this case, your x value, your first value is your input, and the second one is your output. We could have them as graphs, because we have our x-axis on the horizontal axis here and our y-axis on the vertical. So when we take things like ordered pairs, we can graph them. So here we had an input of 1 and an output of 1, an input of 1 and an output of 2, and so on. Or as rules. We can write rules for relations also. So many different ways to represent relations. So a function is a specific type of relation that pairs each input with exactly one output. So that input only has one output. The domain is the set of all possible input values. The range is the set of all possible output values. An independent variable is the variable that represents the input variables of a function. It's called independent because it can be basically any value. It's independent. It can be whatever it wants. But the dependent variable is the variable that represents our outputs. And this variable depends on what the input was. So therefore we call it the dependent variable. All right, so we're going to be determining whether relations are functions here. So they've given us a couple examples. We're going to start over here with example A. So we have a bunch of ordered pairs. And remember, in order for it to be a function, we have to have every input paired with exactly one output. So in this case, I've got the input of 4, and I see it twice, and it's paired with 0 as an output, and it's paired with 3 as an output. And that means that this guy is not a function. So no, that one is not a function. Let's look at this guy. So I've got the input of -1 paired with 4, the input of 3 paired with 15, and the input of 11 paired with 15. So this guy does work as a function because every input is paired with exactly one output. Now you might be thinking, well, 3 goes to 15 and 11 goes to 15. It still fits the definition. This input of 3 only has one output. This input of 11 only has one output. It's true they share the same output, but all that matters is that each input is paired with exactly one output. Let's look at this table. As I'm looking at the inputs in this table, I notice that there are 2 zeros. 0 paired with the output of 5 and 0 paired with 6. So this one is not a function because inputs can only be paired with exactly one output in order for it to be a function. All right, well, let's talk about graphs real quick. There's a cool trick with graphs. A graph is going to be a function when it passes the vertical line test. And the vertical line test basically says that when we're looking at a graph, if we could draw a vertical line at any point in our graph and it passes through no more than one point on the graph at a time, it passes the vertical line test. So basically here I've got some dots on my graph. And if I can imagine that my hand is the vertical line here, at no point as I'm going across will my hand pass through 2 points at exactly the same time. So this guy will be a function. So let's try the same thing with this graph. If my hand is the vertical line as I'm going across, when I'm right here, my hand is going to go through 2 data points at the same time. So whatever this x value is, let's say it's 2, it's got two different outputs. So this guy is not a function. All right, let's take a look at this one. So I've got this line going up here. Imagine this line is made up of data points, and as my vertical line goes across, it's never going to pass through more than one point at a time. So yes, this one is a function. So here's another one. This time the data point looks like a V on its side, and if my hand is the vertical line, as soon as I'm going through this, I'm almost always passing through 2 points. So I'm passing through this point and this point at the same time, so whatever this input is, maybe like 1, it's got 2 different outputs, so no, this one is not a function. So the vertical line test can help whenever it's a graph and you're trying to look at it and decide if it is or is not a function. So what if I'm being asked to identify the domain and the range and I'm looking at a graph? So remember, the domain is the list of all of the possible inputs and the range is all of the possible outputs. So let's start with this first graph over here. So the domain would be my inputs or my x values. So I've got a point here that is at -3 and then down 2. So in the domain, I would add a -3, an input of -3, and an output of -2. For this next point, I've got -1 as my x value, that's my input, and my output is 0. For this point right here, my input is 1, my output is 2. And for this point here, my input is over 3 and my output is 4. In this graph, I'm going to do the same thing, except this one, they're connected by a line. So my domain points are still my x's and my range points are still my y's. They're just going to be a little bit trickier to identify. So I'm going to start right here over on the left. So it's over 2 to the left. So in the domain, I'm going to put -2, and in the range, down 1, -1. So I'm going to follow the line. The next point it goes through is right here. So that would be an input of -1 and output of 0. I'm going to keep following the line. Here's my next point it crosses through. So that would be an input of 0 and output of 1. Right here it goes through. My x value is 1, so that's my input or my domain number. My output is 1. Here's my next point. Input of 2, output of 1 again. And my last point, over 3 and up 2. Since I see in my range that I have some numbers that are repeating, 1, 1, 1 here, I don't need to write them all those times. I'm just going to write it once. Once it's in the range, we don't need to write it again and again. So I just got rid of those extra ones. All right, let's look at one more example. This is a trickier one because this line is kind of curving and it's hard to exactly pinpoint what all these points are. But I do notice that when I get down here to 0, it's curving back up. So one thing that I could say in a case like this, since I've got this curving line, is that I know my domain starts at 1, and 1 is part of the domain, and it goes across the graph over to 5. It never goes below 1 or above 5. So I could say for my domain that 1 is my kind of bottom, my minimum, and 5 is my max. So I could write an inequality for my domain. I could do the same thing for my range. My range maxes out up here at the top at 4 and at the bottom at 0. So for my range, it can't be less than 0 or greater than 4. All right. So let's take a look at one last problem here. The function of y equals negative 3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. So the first thing they want us to do is identify the independent and the dependent variables. Well, x was standing for the number of gulps of juice we took, and y was the amount of juice that was remaining in the bottle. So since the amount of juice remaining depends on how many gulps you've taken, the gulps is going to be your independent variable. That's the one that it's kind of up to you. How many gulps are you going to take? Depending on how many gulps you take, that will determine how much juice is remaining. So y is your dependent variable. So let's say the domain in this problem is 0, 1, 2, 3, 4. I've made a little chart here, and we have our expression negative 3x plus 12, and this is going to help us get our outputs. So if our input is 0, we have negative 3 times 0 plus 12. This would give us an output of 12. If we put an input of 1 in here, negative 3 times 1 gulp plus 12 gives us 9. Negative 3 times 2 gulps plus 12 gives us 6. Negative 3 times 3 plus 12 gives us 3. Negative 3 times 4 plus 12 gives us 0. So after 4 gulps, there is 0 ounces of juice left in the bottle. So our range is 12, 9, 6, 3, and 0.